All right, good morning and welcome to another calculus session. So we are moving on to no, it's not a new topic, but it's the next topic. It will be let me just check my table of contents here. My topic list will be number 9. We are skipping the trigonometric functions because for our purposes, they take a long time and we don't get a lot of reward for that time investment at our level. Most applications of trigonometric functions worth doing are a little bit complicated. So at this early stage, we'd be doing trig functions just for the sake of them, and I feel that there are more important things to spend our time on. So we are not doing topic 8 this time. We are moving to topic 9. Now it's titled graphing, and we're certainly going to focus on graphing functions, but in order to do that, it's really analyzing the function. And in that analysis, we see all the properties of the function, and it's very nice to visualize it by way of graphing. So I focus on graphing as my end goal, but it's really the analysis process. Then the graphing is my visual reward for all that work. Now, we are going to have some steps that will break this up into, just for convenience. Now, most books do it slightly differently. They have more detailed steps, but once it gets a little bit high in the number of steps, like 10, 11, 12 steps, I can't remember all these things anymore. I can really only count on one hand. So we'll have 5 steps. Well, maybe not skip 2, 3, and 4. We'll have a nice manageable number of steps so it doesn't get out of hand. Let me just do that as well. Because if I only have a few steps, then I can remember them easily. It's never a big issue. But you'll see books just being way too elaborate and detailed on this outline. And then I have no idea what I'm doing anymore. Now, I will say within these steps, there are a few things to do, but I feel that it's better to do it this way. So the first thing, just like any problem, is just look at the function. Just look at the function. This is before I write that, I'll say here, this is very much my warm-up step. And it's not a step in the same way as the others are. I need to start somewhere. But people skip this. People rush to the complicated mathy stuff, and they don't just stop and look at the function that they have to work with. Because often if I identify the function, and we'll go through a few of these examples, if I identify the function like a polynomial and things like that, there are certain properties that will always come with that kind of function. And even if I conclude, well, I don't know this kind of function, I don't know what to do, that's still information, like, okay, be a little bit more careful, this is not a familiar function. But I don't want to skip just taking a few seconds. Just look at what I'm working with. Is it easy? Is it familiar? Is it not? And then act accordingly. So that is the one thing that people miss. They just rush and they didn't think where the sticky points in the upcoming steps could be. And I want to start my graphing. I want to start my visualization. And the easiest thing to do is a y-intercept. So I might as well find that while I'm looking at the function, because it's super easy to do. Always plug 0 in for x and calculate it. that's always going to be f of 0. Right? So that's easy to do. I might as well do it, feel like I'm making progress. But step 1 isn't really a big progress step like the others are going to be. Okay, so let me give an outline here, but I don't want you to worry about the steps that are coming up. We're going to take them one at a time, and then at the end, for each kind of function, put them all together as well. So there's going to be a lot of time, but maybe it's good to have an idea of what's coming up. The second step, I'm going to look at asymptotes. Are there any asymptotes? What is the long-term behavior? Even if the y values go up to infinity, I want to know what is happening long-term. Now, asymptotes can be vertical asymptotes or horizontal asymptotes, right? So there are more sub-questions within this step 2. Fair enough. But it's the topic of asymptotes and long-term behavior. Then, if I look at a graph, sometimes it's going to go uphill, sometimes it's going to go downhill. We say it's increasing and it's decreasing. So I want to know where is the function or the graph increasing and where is it decreasing. Those areas, identifying those areas or x values where this is happening will help me identify the shape, the trend of the graph. And then we'll clarify it when we get there, but we will also need to know what I call the bend in the graph. Now, right now, that might not mean much. We will deal with that when we get there. And then at the end, we want to put all the information together. They all give me information. They're all pieces of the puzzle. And the puzzle is going to be, what does this graph look like? Each steps, mainly steps 2, 3, and 4, will give me pieces of the puzzle. I still have the task of putting them together to completely see the graph. Because in isolation, and that's how we're going to start. We're going to start with just step 2 in isolation. And just from step 2, I won't know what the graph looks like. It's not all the pieces of the puzzle. Just isolating step 3, I do need to practice that and see what I need to do there. But it's only a portion of the picture. Just step 4, it's only a portion. Only when I see all of the information can I put it together and really know exactly what the graph looks like. So it's a very important step to be able to tie everything together and draw the graph as well. Okay, but there is always the risk that we're getting ahead of ourselves, and I don't want you to obsess about steps that are still coming up when we just want to do one step at a time. So let's have some examples. We're just going to clarify the warm-up step. So I'm just going to, maybe these examples will come up again, or maybe not, I don't know. I'm just making them up to give me an idea of what kind of functions I could come across. So here I can identify this is a rational function. Rational function. And with a rational function, I will systematically build my experience and start to see, if I haven't already, that there are potential asymptotes. often a rational function will have asymptotes. Vertical, horizontal, I need to check. Often that is the case with rational functions, right? Because it's built on a basic function that has asymptotes. Now, once I have higher powers of x, the shape might be drastically different, but it's still linked to this basic kind of function, which has those key properties. So for vertical asymptotes, I like to do vertical asymptotes first. That is going to be for a rational function, in our case, where the function is undefined. We are keeping things simple, so I am not going to have little holes that actually factor out when it's undefined for us in our examples. It's going to be because there's an actual vertical asymptote. So we're keeping things fairly simple. So in this case, now I don't want to get ahead of myself. We're not doing step 2, which is actually the asymptote question. But I do want to, especially in the rational function case, already think, well, in rational functions, the asymptote question, the asymptote step will be the big one. And also horizontal asymptote, that is when x is going to go far in either direction. What is happening to the graph? And that's very much a question that is going to have something to it in the case of a rational function. And then, of course, I can do the y-intercept just to get my graph started. And that's going to be f of 0. I plug in 0. What can be easier? I get 0. So often we then start the graph and say, oh, well, I can feel like I've made some progress. There it is, 0. Something is on a graph. I have no idea what this graph looks like, but I've made some progress, feel good about myself. So rational functions. Now, this step 1, like I said, what is this square doing here? It's annoying me. I don't know where that comes from. Anyway, rational functions, or no, functions in general, for which I'm trying to graph these steps. Step 1 is not at the same level as the other steps. It's just a warm-up, just getting me in the right mindset. Like, okay, I need to think, what do I watch out for these functions? Oh, it's a rational function, so asymptotes is probably going to feature here. But I'm not doing much more. If I look at a function like this, let's keep it simple, like that. It's important to think, well, this is a polynomial. And with that comes a lot of properties that I immediately know. Polynomial, the function is going to be defined for all x values. There are no asymptotes for polynomials. So if we don't stop and think, I see people, let's suppose you have to do all the steps for this question. I see people not taking the time to identify the function and think what that means. And they just want to go to step 2 and think about asymptotes and waste a lot of time when a polynomial will never have anything significant to do in step 2 because of the type of function. So I can save myself a lot of time by identifying the function and just knowing what to watch out for and what to not worry about at all. There's not much to do, but it has value. Find the y-intercept, feel good about myself, it's 7. I can then, if I wanted to, start this visualizing my graph process, but I don't know that much, right? I have a point on the graph, but it's better than nothing. better than nothing. And it's, again, important to understand that no single step is going to tell me what the graph looks like. I need them all to get that full picture. Let's call this guy G. Let's say Lexto. Actually, what I'm going to do at the bottom of this, we're just gonna have to put up with this black square. I'm not sure where that guy's coming from. Ah, there we go. Gone. I also want to make a list of the types of functions, mainly, that we are expected to be able to do all these steps and graph all of them. We're not, because that gives me a sense of, okay, this is not overwhelming. I only have 5 types of functions to deal with. Practice each type. I can better prepare myself. I know I'm not missing out in my preparations. So to make it convenient, I have only 5 types of functions as well. See, you only need one hand. You can count all these things. The first one is, of course, we've seen a polynomial. Polynomials. So, of course, I need to eventually make sure that I do all the steps for polynomial examples. That is one example. And the other one is a rational function, sort of the step up from polynomials, in that I have a fraction of polynomials. So again, we just did step 1 for a rational function. Of course, there's not much to do. I'm warming up. But I want to make sure that I do practice every graphing step for this kind of function. Then, where's my, yeah, there we are. Then I have functions like this guy, which has an exponential component. It's not an exponential function, because technically speaking, an exponential function looks like that, or some x's at the top, not really mixed with other things. These guys have exponential functions as components in them. There could be other x's on the base level and all kinds of stuff. But it turns out the presence of this exponential component, I'll call it, doesn't have to be a factor, that really sort of dominates the behavior of this function. Exponential functions are very, I like to say, dominating, and we'll see what I mean by that as we go. So I see, so let's call that exponential, this is not official, components. It's not very specific, it's not really a classified type of function, but I'm going to classify it. Anything that has an exponential function somewhere in it. So now I identify this type for us because I see an e to the x, or some e to the something. Now we'll mainly stick with the natural base, but it could technically be anything. So once I see that, okay, so at this stage, admittedly, this is our first step into this analysis graphing discussion. I don't have a lot of experience with how these functions behave, what to do with them. That'll take time. And as we see this kind of function in each of the graphing steps, asymptotes, increasing, decreasing behavior, and the bend in the graph, and putting everything together, we'll gain some experience, and we know a little bit more what to expect. So right now, it can happen that I have limited experience. I don't know what to expect. Don't know. I'm just going to find the y-intercept and move on with my life. But not knowing is adding information, because now I have to be careful at every step. I haven't seen this before. I need to watch out. That's still something I want to be aware of. If I plug in 0, I will get 0. Now we'll see, I want to make a note of this because it's going to make my life easier later on very often. I don't have to work with the function in its original presentation. Because I see e to the negative x, I could write this as x over e to the x. My personal preference very often is to avoid negative exponents or exponents that look negative, like this one. I don't like that negative sign. It makes me uncomfortable. I just don't have a good intuition about negative exponents, whereas if I rewrite it, I feel a little better about it. Personal preference. But often we'll see it's going to make things much easier in my opinion. Right now, I don't have much, and that's okay. I've only identified that this is a type of function that I'm going to see in a different light. We need some experience, and that's okay. It's not a big deal. It just takes time. Then let's go back to f here. We can have something like this. You'll see these guys in the problems as well. I don't have specific problem numbers now. I'm just making them up because I know they're in there in one form or another. And then they have some variations we can eventually look at. So here I have sort of the other side of the previous type. Here I have some logarithmic component. Now we're trying to keep these things simple, right? We're not going to mix these two and make it complicated. You can always make things more complicated. That's not our goal here. Our goal is to have a manageable volume and variety to see what we need to see while not having it be too overwhelming. So my next type is a function with a log component. That then is going to kick it out of the rational function type. Because as soon as I have this log component, even in between other x's, other stuff, it kind of dominates the behavior a little bit. It dictates how this function is going to behave to a large degree, not completely, of course. And again, like before, I have no experience with this kind of function. I look at that, I have no idea what that looks like, nor should I. It is going to take time. So I just want to be careful as I'm building that experience, and the only thing I can do right now is find a y-intercept. Well, I made a point of asking because it is not 0. And I can also put it into my calculator, right? I can put it in and say, let's do it. ln of x divided by, not x, of 0 divided by 0. Let's see what MathBot says. MathBot is going to be unhappy. So there are actually multiple things. I'll make a little side note here. At the very least, forget the log component. I'm dividing by 0. That's not going to happen. So this guy alone is going to be an issue. But I can't divide by 0. I can't get a number. I can't get a real number. But let's suppose we made it a +1. Now that's not an issue anymore. If you remember the natural log function, right? You have to be able to close your eyes and, oops, that was a little wobbly. And visualize what's happening here. It's not defined on there's no crossing of the y-axis. That's where x is 0. That's where the input is 0. There's no left side. It's not defined at 0. So it was sort of a double whammy originally. I was dividing by 0, giving me that error. But also the presence of the log component is going to eliminate all 0 and negative x values. I just can't plug them in anymore. Can't plug them in anymore. Not defined for x less than or equal to 0 because of the mere presence of the log. It changes the function completely. So I have to go here and say it's undefined. Undefined. And there is no y-intercept. But it's important. See, if we skipped step 1, then I might not be aware of all this. And it's a lot of information that now I had my warm-up and I see, oh, there's a log component. So I'm really only doing half a graph. I don't even have to worry about negative numbers. And I can take that awareness with me into the next steps. And I've seen people just blindly doing the steps 3 and 4 or whatever, and they never really took the time to think about what the type of function automatically tells me. And that makes things easier later, very often. Which is why I've more sort of recently included that warm-up step, because skipping it can be dangerous. Now I'm aware, moving forward, if this was the start of a bigger question, I'm aware of, oh, this log component is always going to be this issue of being undefined. Negative x values will never be something I have a graph for. It'll never be something I'm interested in. And I need to remember that, especially with this guy. Especially with this guy, as I go into a derivative, because its derivative doesn't have a log. Its derivative is 1 over x, just that piece. And then suddenly that function is defined for negative x values, whereas the original is not. And weird things happen, and I need to know. So don't skip this warm-up. It's there because it has a lot of benefits. All right. I want to see. I don't know if I want to see it now. Let me think. Let's see this function. Call it f again. Why not? X to the negative 1/3 plus x to the 2/3. Now, chances are you've never seen that kind of function before. Or, that's one. Or you think that's a polynomial. One of those two things usually happen. This is not a polynomial. I'll say it again. That is not a polynomial. A polynomial has positive powers of x. Or a constant, I guess. It's technically a 0 power of x. But the non-trivial polynomial has positive integer powers of x. Meaning if there's a negative power of x, that's something else. If there is a fraction power of x, that's something else. Now, luckily, we can group the negative and the fraction powers all together. It doesn't matter if there are negative numbers. It's the issue of having fractions in my exponents. So I'll just call this fraction powers of x. Maybe this guy has a name. I don't know what his name is, because I'm grouping more variety in R number 5 than there actually is in classifying these functions, because we don't need to be that complicated. If there is a fraction as a power of x, it might not be all of them. I could have this, fraction power of x. As soon as there is a fraction, positive or negative, I don't care. Usually they are all of them, but not always, not always. This is a function more than the others where I have literally I've never seen this. The best thing I've seen is square root of x. That we've seen. Because this is x to the 1/2. And it wasn't the same as anything else. It wasn't a polynomial. It has its own issues. But when I now make one negative and I then combine it with other powers, I don't know anymore. I don't know anymore. So it's certainly something that I'm going to have to build my experience to understand what do I expect here. Fraction powers. What do I expect is going to happen here? Now, we, at the very least, want to find the y-intercept. So that's a 0. And even that might seem a little confusing for some. Because this, again, this function in its original presentation often will look like this, as multiple terms. And my general rule is the same. Just like for this top example, I don't like to look at negative exponents if I have a choice. I rewrite it to look nicer. Because then, similar to here, if I see a rational function, if I see a function with a numerator and a denominator, I immediately wonder about vertical asymptotes, right? Because dividing by 0 is going to create that in general. So when I have a negative exponent, often they're trying to hide the fact that there is a numerator and a denominator. And I want to know that because that's important for my vertical asymptote question. It's always going to be, where is this denominator 0? So in this case, it's going to be when the denominator equals 0 in the case of rational functions, right? It's the only situation that's, for us, going to create a vertical asymptote. Well, it is the only way. But in other cases, that negative exponent could hide the fraction aspect of this function. And I need to see that fraction aspect so I can ask, when is the denominator 0? That's going to create vertical asymptotes. It's an important question later on. So I want to set myself up to be aware of upcoming questions. Here as well. I see a denominator of x plus 1. Luckily, I see it from the start. So I can say, oh, when is this guy 0? X equal to negative 1 is going to have a vertical asymptote. That's a step 2 question, but I'm setting myself up for an easier time in the future by warming up. And part of the warm-up is, does this function look as nice as I want it to look for the upcoming questions? And the negative exponent, in my opinion, less than ideal. So we'll put a pin in that. I'll say here, I may want to rewrite this. May, because it's not essential. It's a choice that I'm making. And in my experience, it's a good choice. How do I do it for these kinds of functions? Here is the rule of thumb. The rule of thumb is not a rule. It's just going to be a handy attempt that will almost always work. I'm going to take out, I'll just take as factor, or as common factor, the, how should I say it? Smallest or most negative, smallest on the number line, power of x. If you think about these powers of x sitting on the number line, which one is further to the left? It's negative 1/3. That's the one I'm going to take out. So how does that work? It's okay if you are not super comfortable with this, but that's not a reason to not do it. that's a reason to practice it more, because it's going to be very handy. I'm going to take x to the negative 1/3 out. It's not an obvious common factor. I'm going to make it a common factor. So then I have to ask myself, what do I have to have in the brackets so that when I multiply this guy in, I get the original function? Now, hopefully, obviously, the first term is going to have to be a 1, because x to the negative 1/3 is exactly what I'm looking for. So I'm just going to multiply it by 1. Sorry, I didn't actually ask, but good, yeah. Some people need some time, so I'm just going to ramble on a little bit, because it's hard for people to find that second one sometimes. It's all good. No, it's good, because you can check for yourself. Now, I just want to give people some time. In order for me to get x to the 2/3, I'm obviously going to have a power of x here, right? It's going to be some power of x. We should at least agree on that. So now when I multiply this in, I'm going to get, let's put it over here, I'm going to get x to the negative 1/3 times x to the something. And I want that to result in x to the 2/3. Okay? I don't know. I'm trying to find what's that question mark. I know my target. My original function cannot change. I just want to write it in this way because, trust me, it will help me moving forward. There is no doubt. It's going to be nicer. But that means I have to understand this. I have to know what is this new power of x that's inside the bracket, because it's going to have to be multiplied by the outside guy, which in this case is x to the negative 1/3, and it'll then have to result in x to the 2/3. Now, when I multiply with the same base, I add the exponents, and that should be 2/3. That means the question mark is a 1. That means I'm not going to write the 1, because if I write nothing, it's just x. Now I'll admit this is not necessarily the simplest thing for you at this stage, and that is okay. But that is not a reason to avoid it. That is a reason to do more of it, spend more time on it, so that it becomes super comfortable. Because often, for fraction powers of x, rewriting it this way is going to make my life so much easier. Why? Because now, oops, I'm in eraser mode here. Now, I can see that actually this function does have a denominator. It wasn't obvious originally at all that this is actually fairly close to a rational function. It's not a rational function because the bottom one is not a polynomial, but it actually has a lot more in common with a rational function than anything else. You can also write x plus 1 over cube root of x. You can swap those around, right? Depending on what you're more familiar with. But now I see, oh, there is a good chance that my denominator can be 0. That's going to quite possibly create a vertical asymptote. But I didn't see it originally. It's so well hidden in this original presentation. I need to not fall for that. I need to see the function for what it truly is. And when I avoid negative exponents, it makes the y-intercept calculation easier anyway for me. Y-intercept calculation, 0. And now I see clearly I'm going to divide by 0. And again, it's going to be undefined. It just makes everything easier. So there is no y-intercept. That in no way tells me what the graph looks like. I have no clue what this looks like. There's so many little variations. And if I change one of these fractions, the graph could look drastically different. I don't know what this looks like. Personally, actually, I have no idea what it looks like. I have a guess, but that's not good enough. We need those other steps to add pieces to the puzzle until it's super clear. Right now, I'm just warming up. And this function is the last in my list of types of functions, probably the most difficult one as well. We're going to see it again. It's going to come up for each of the steps that we look at. We're going to look at these types of functions, and we'll build that experience slowly over time. But of course, the stranger the function, the more time I need to get this experience. For now, we haven't done much, but for these kinds of things that may be a little uncomfortable for you, spend the time, make it comfortable. I am not wasting your time. If I say this is going to be useful, it's going to be useful. And any effort you put into this will set you up for success more later. I'm not wasting your time. This is as streamlined as I could possibly make these things, because we don't want to overcomplicate things. We want to look at it as efficiently and as cleanly as possible.